Welcome to the world of Python objects and object-oriented programming. Now, I want to say this upfront. This chapter is going to feel a bit different from the chapters you've gone through so far. Up until now, we've been writing programs, learning syntax, working with data types like strings and lists, and building up your Python muscle. You won't learn everything there is to know about it in this one chapter or even this one course, and that's totally okay. The goal right now isn't to master OOP, but to get familiar with the language, the patterns, the structure. I want you to hear the words, object, class, method, attribute, and not panic. Let's make them part of your vocabulary, even if they're not fully clear just yet. But this topic, object-oriented programming, is on another level. It's deeper, richer, and honestly, it's something that unfolds over time. Let me be real with you. I've been programming for a long time, and I still find new beauty in object-oriented programming. You see the outside, you use the outside, but you don't need to peek inside. Instead of you writing 2,000 lines of code to handle strings, someone did that already and gave you a string object. You just call methods like upper or find, and it does what it's supposed to do. Some are created by you. They talk to each other, pass data back and forth, and get work done. That's beautiful, right? Someone else has already done that hard work for you. You've used lists, right? You've written my underscore list, append item. That little append function, that's called a method. Every time you do that, you're telling a list object to perform a method that was defined for all lists. One object calling a method defined inside itself, transforming the data it holds. You didn't have to build it. You just used it. Welcome to the magic of abstraction. And my underscore list, that's an object and instance of the list class. That dot in between, it's not just decoration. It's Python's way of saying, hey, look inside this object. There's a function or attribute in there that we want to use. You've already been using objects. You just didn't know it. Let me give you another example. You've also used string methods like lower or strip. Same shape, made from the same design, but each one is its own thing. So what is an object? Really, think of an object like a self-contained gadget. It has buttons you can press methods, it has data stored inside attributes, and it might have some hidden internal logic. Just like how a coffee machine works when you press the brew button. You don't need to know how it works internally to use it. You can make as many objects as you want from a class. Just like you don't need to know how a coffee machine works to press the brew button. You trust that pressing that button will do the job. That's the core idea of abstraction in object-oriented programming. This idea is powerful because it allows complexity to be managed. Programs are built out of objects talking to each other. Fido is an object and instance of that class. Bark is a method. Name is an attribute. This is how Python lets us create little bundles of data plus behavior. If you want to see what that object can do, you can call dir Fido. That will show you all the attributes and methods available. Think of it as packaging logic with the data it applies to. Every Python program you write is basically a little orchestra of objects. Some of those objects are strings, lists, or dictionaries. You're already orchestrating this interaction. Name equals input, enter your name. Name equals name. Strip closing parenthesis dot title here. Name is a string object. It receives input, then it calls. Strip, then dot title. That's object interaction. You'll build your own blueprints, and others will use them without needing to know what's inside. We're going to build our own classes soon, and when you do, this will all start making more sense. You can also combine objects. You're learning a powerful concept, one step at a time. You've already been using objects. Now you're going to start making your own. That's the power of encapsulation and abstraction. Improvements can happen behind the scenes without breaking your programs. That's the power of OOP. It hides complexity and gives you clean, simple interfaces. Names equals Alice, Bob, Charlie. This is a list object that contains string objects, so you've got objects inside objects. It's all objects. Let's define some terminology. A class is like a blueprint or a template. It defines what an object should look like and how it should behave. An object or instance is a real, usable thing built from that class. A method is a function inside an object you call it to make the object do something. An attribute is data stored inside an object. Let's say we're making cookies. The cookie cutter is the class. The cookies are the objects. Let's take it further with an example. Here's a mini class, class dog. Def underscore underscore init underscore underscore self. Name, self. Name equals name def bark self. Printf self.name says woof. Now we can use it. Fido equals dog Fido Fido. Bark boom. Dog is the class. Boom, dog is the class. Behind the scenes, Python tracks everything. When you type Fido, it'll say class underscore underscore main underscore underscore dog. Python knows that Fido came from the dog class. It's like Python is self-aware. It knows what class created this object, what capabilities it has, and how to use them. Why does this matter? Because once you understand classes and objects, you can build tools like Python's built-in list, string, and dictionary objects. The people who wrote the Steamer class, they probably wrote thousands of lines of code. But we just do name, upper, and move on. And the coolest part, when Python improves its string object under the hood, your code doesn't change. Wrapping up for now, I want you to just let this sink in. Don't worry if some of it feels abstract. That's normal, so take a breath. You're not behind. Let's go make some classes.